In this video tutorial, we're going to look at volcanoes, more in particular volcanic eruptions and hazards. So stay tuned. What is a volcano? A volcano is a vent or chimney that connects molten magma or molten rock from within the Earth's crust to the Earth's surface, right? So basically, a volcano is an opening or a vent in the Earth's crust. What they meant is that the magma chamber is at the bottom. This is at the core of the Earth. So we'll just write that in. So this is the core of the Earth, which is very hot. The magma chamber rests there. The conduit is like the pipeline. So think about a pipe system where the core is like the reservoir and the conduit is the pipe that streams the magma upwards, and the magma stream upwards due to pressure. The volcano is conical in shape because of the various layers due to eruption. Sometimes you have a sub-vent forming at the side of a larger volcano. Okay, so this whole area is a volcanic cone, and a volcanic cone looks like this, right? And this is the magma chamber below the Earth's crust, and it goes up through the vent, and there's explosion, steam, gas, dust, and stones. This lava flows to the side, forming new layers. Every time a volcano erupts, a new layer is formed. A new layer of land is formed around the volcano. So that's why it looks stratified here in the diagram. This is one layer, this is another layer, this is a layer, a layer, a layer, and so forth. So judging from this volcano, we can say that there were 1, 2, 3, 4, 5, 6, 7, 8, 9 eruptions. The most recent eruption remnants is to the top. When the volcano erupts again, it will just flow down, right? And this little volcano to the side can also flow down. A volcano, as I repeat, is a vent or chimney that connects molten rock or magma from within the Earth's crust to the Earth's surface. The volcano includes the surrounding of the cone of the erupted material. So the cone of the volcano is formed due to erupted material, which was material that flowed over from the volcano's vent. How and why do volcanoes erupt? Hot molten magma is buoyant, has a lower density than the surrounding rocks, and will rise up through the crust to erupt on the surface. This is the same principle as if we had hot air rising. Example, how a hot air balloon works. So basically, we have hot air that keep the balloon up in the air stabilized. Same way, the hot air and pressure that rises from the Earth's crust, from the mantle throughout the crust towards the surface, works like this. It puts pressure and it pushes it upward. When magma reaches the Earth's surface, it depends on how easily it flows. Its viscosity determines the flow. Viscous lava, and this is something we will look at now. Viscous lava is sticky lava. Okay, it takes a while. It looks like it's rolling. Sticky, thick lava. Now, lava is basically magma, but once it reaches the Earth's surface, it's considered lava. Below the Earth's surface is considered magma. So when magma reaches the Earth's surface, it depends on how easily it flows in terms of its viscosity. At the amount of gas, H2O is water, carbon dioxide, and sulfur. Sulfur is a big thing that erupts from volcano. Sulfuric acid especially. It has in it and how it erupts. Large amounts of gas and a high viscosity or sticky magma will form an explosive eruption. So think about a scratch bomb. It's been compressed there, and when it erupts and when it bursts out, it tends to sound louder. It's the same thing. When a volcano is erupting, try multiplying a scratch bump by a cajillion, and that is the sound it makes, right? Viscous lava is very thick lava, so it's pressured. Think about it, shaking a carbonated drink and then releasing the cap. So take a Coke, shake it up and open it, will explode. Except think about the stickiness of the lava and how much it will be. Small amounts of gas or low viscosity, so lava can also be runny or very fluid, so it just flows. So small amounts of gas or low viscosity or runny magma will form an effusive eruption, where the magma just trickles out of the volcano and flow, right? So the flow of volcano could be viscous or very thick, or low in viscosity or runny. Explosive eruptions. Explosive volcanic eruptions can be catastrophic. It erupts tens of thousands to thousands of kilometer cube of magma. It sends ash clouds 25 kilometers up into the air. So this is the volcano top in this picture here. And all this is the steam and gas clouds going up. So it don't just hamper our atmosphere, it enters the stratosphere, right? And after the stratosphere is the exonosphere and then space. They have severe environmental and climatic effects. So when a volcano erupts, all this is like pollutants to the air, right? And this could cause a lot of damages to the health of a person surrounding. It can damage marine life. It can cause the ozone layer to be more depleted, right? In general, it is hazardous, right? Above large eruption, column and ash clouds form an explosive eruption such as Mount Redoubt in Alaska. So Alaska is a volcanic country. There is volcanoes there, but the thing about these volcanoes, it lies on top of ice, okay? It's a little bit different to what we have in the Caribbean. So there are three products from an explosive eruption. There are ash falls, pyroclastic flows, and pyroclastic surge. So this here is the city of Montserrat. This is an island. There's nobody living there now because of this volcano. There's an active volcano on the island of Montserrat. Pyroclastic flows on Montserrat bury the capital city. So the ash falls and the pyroclastic flow literally covered buildings. It was that deep. It was that amount of lava being ejected. And this is what it looks like from a distance. The volcano is erupting and all is this steam, gas, and ash coming out. It is extremely dangerous. You can't even see going through that, much as inhaling all the sulfuric acid. Then there is effusive eruption. Eruptions are characterized by outpouring of lava on the ground. So this is where it is very runny. As you can see, it flows like a stream out of the volcano. And eventually it will cover cars, right? Everything in its path will be burnt. Trees, cars, houses, animals, etc. This is a volcano in Hawaii. Notice the vent of it is very broad, right? And it's bubbling. It is exploding, but it's not up in the air like how the pyroclastic flows would be. It just flows down the volcano like a stream, and a stream with tributaries. But even though it's effusive and runny, it will burn everything in its path. So now we move on to volcano monitoring and hazard mitigation. So volcanic fatalities. 92,000 in Tambora and Indonesia, 1815, right? In the year 1815, 92,000 people died. In Indonesia, again in 1883, when Krakatau exploded, 36,000 people died. In Martinique, which is a Caribbean island, Montpellier in 1902 had a fatality of 29,000 people dying. In Mount Unzen in Japan in 1792, there was a fatality of 15,000. So these are just facts, but I would encourage you to learn them because in your exam, or if you're given a question about volcanoes, it is very important that you understand the facts behind it. So you can say, for example, in the year 1883, the eruption of Krakatoa in Indonesia had a death toll of 36,000. So these are facts that you need to understand and learn to add meat to your answers in the exam to get full marks. But volcanoes cause fewer fatalities than earthquakes, hurricanes, and famine, right? But all these things are diseases and hurricanes that we could monitor it, yes, but we have a little time to evacuate. Earthquakes is unpredictable. Yes, we have earthquakes coming in and we have a few signs of it, but there's nothing to tell us, we're going to get a big earthquake today. Volcanoes have a longer period before eruption. So before a volcano erupts, you're going to feel several small earthquakes. You're going to find underground animals coming out. You're going to find a general change in the Earth's surface. And this might be at least 2 to 3 weeks before the actual eruption. And then you'll start to hear bubbling and rumbling in the crust. And then eventually it will erupt. By then, we should have evacuation taking place. Some volcanic hazards are pyroclastic flows, lahars or mud flows. So sometimes when the volcanic ash mixes with water, so volcanic ash mixing with water forms lahars or mud flows, and this is very dangerous for crops and it causes the drain to be clogged and so forth. And then we have pyroclastic falls, which is like steam, gas, and ash that pitches out through into the in the air and that reaches the stratosphere. Then we have lava flow, whether it be viscous or low in viscosity. It flows out to the surface of the earth and cause damages. Then we have noxious gases, high sulfuric contents. Carbon dioxide is very dangerous to human and animals and the environment. And then we have earthquakes. So earthquake is a hazard that results before a volcano erupts. Even during the eruption, an earthquake could happen because remember, with this large explosive device that we have on the surface of the earth can shift the plates. Pyroclastic flow, here's an example. The eruption of Vesuvius in 79 AD destroyed the city of Pompeii. So this is way, way before anything, right? But Vesuvius is in the North Poles region, Mount Vesuvius. You can research it. If you ever watch a movie, Journey to the Center of the Earth, they went there. Then we had, this is what it looks like. This is Pompeii in 7980. On August 24th, 7980, Mount Vesuvius literally blew its top, erupting tons of molten ash, pumice, which is small volcanic rocks and stones, and sulfuric gas miles into the atmosphere. Pyroclastic flows over the city of Pompeii and surrounding areas. So this is somebody who died as a result of the volcanic material touching them, right? It's buried and solidified in the gas and ash. Then we have pyroclastic flows of poisonous gas and hot volcanic debris engulfing the city of Pompeii. Suffocating the inhabitants and burying the building. So these are people, all these are bodies that were buried and it's still digging up and finding them. And this is a dog that died. The city remained buried and undiscovered for almost 1700 years. So this volcano erupted and 1700 years later, the city is still buried under all this ash and volcanic material until excavation began in 1748. So when they excavated the land and started to dig up, they saw the remnants of this volcano and the extent it reached to destroying. This is where they found all the bodies that we're seeing here in this picture. Vesuvius today. Vesuvius remains a hazardous volcano with heavy populated flanks. Around 1.5 million people live in the city of Naples alone. Naples is situated approximately 30 kilometers from Vesuvius. So this is an image of a satellite image. This is Vesuvius. If you look very closely, you can see the vent of the volcano. So that's to tell you how large that it's so huge that we could see it from a satellite image, right? And this is the city of Naples here. So when Vesuvius erupts, Naples will be one of the cities under threat. Pyroclastic flow can flow up to 100 kilometers from the source. So yes, 100 kilometers from the center where we see the vent to Naples could definitely reach. This is Montpellier in Martinique in 1902. So here we have a before and after shot of the volcano, right? Before and after the volcanic eruption. So here we have a nice marina before. You see the nice marina with the boats. It's a black and white picture because 1902 had no colored camera, okay? There's a marina. There's a lot of buildings. You'll notice. And then after the volcano, marina is gone, buildings are burnt, and the land is left barren. An eruption of Montpellier in 1902 produced a pyroclastic flow that destroyed the city of Saint-Pierre. So the eruption in Montpellier in Martinique in 1902 was very catastrophic. It destroyed the entire landmass as we see it. 29,000 people died and only 2 survived. Why? Why do you think this is so? Why do you think people lived? Because when people saw the eruption taking place, right, they basically went into hiding. There's Barnum and Bailey, the greatest show on earth, they call them. These were a group of people with basically 2 people who hid in a tunnel cellar. They were left underground for a couple days, but eventually they made their way out. It wasn't that covered. Right, so while 29,000 people died, 2 survived because they ran and they took precaution. You know, most times during a hazard, whether it be an earthquake, a hurricane, a volcano, before people actually take measures to get themselves out, they tend to panic. And when the panic starts, you don't think straight. So you end up getting caught up in it. And sometimes it could be so bad that you die. So we're looking now at how do pyroclastic flows cause devastation. Pyroclastic flow is a direct impact. Look at it. Think about it. Something is erupting, a volcano is erupting, and this is the amount of steam, gas, dust, and lava that is being flowed out, right? Of course, it's going to be disruptive. Well, a volcano ejects something worse than fire. It is fire related. It's very hot to a point that it is fire. And it is coming out of that. And it will burn everything in its path. It's not like a flood that will rush away everything. It will burn everything in its path. And after days and weeks, it will get cool and it will become a new layer of land, but obviously it is destroyed, okay? We can't really do much around a volcano. You're not supposed to put a population surrounding a volcano because they will be at the first at risk when it erupts. Right here in Trinidad, we have those mud volcanoes. They call it mud volcanoes, but always remember a volcano is something that ejects lava. So they name it mud volcanoes because it resembles what is a volcano except it ejects mud. Yet this can destroy, this causes landslip, it causes the land in which people build right now to be very uneven and houses fall apart. But people know that these houses and the land is not safe to put up any form of structure, but yet they go, the land is always shifting there and they still go and build. So this is people not being proactive, they are being reactive. They will wait for something to happen and then move. Besides the direct impact, pyroclastic flows cause burial. What we mean by that, this is the top of a building. Up to here is covered in volcanic material. Okay, so a lot of buildings and areas are covered. This is the top of a church tower. Look at it. That's usually tall, a tall structure. And it's covered, right? And there's no coming back and getting these houses anymore because that is like stable land packed on top of it, right? That volcanic material is very much like a new layer of land. There's no coming out. Rather now, they could just evacuate and leave it so. Right? So things are buried, houses, stables, land, huge landmass, even a very, even the sea where volcanic material is flowed out into the sea can cause a new part of, let's say, an island to be formed. So it added extra to it. Pyroclastic flows cause burns. Of course it does, because it's hot material, right? So it burns everything in its path when it's flowing out. Pyroclastic flows also cause lahars or mud lakes to develop when the water mixes with the volcanic activities. So for example, hot volcanic activities can melt snow and ice. This melt water picks up rock and debris, forming fast flowing high energy torrent, and it could destroy anything in its path. So now we're going from lava to having mud flows. So it could be thick mud or runny mud, but it will destroy anything such as vegetation and so forth in its path. Then we have pyroclastic fall. We have the ash load. It collapses roofs, it brings down power lines, it kills plants, contaminates water supply, and causes respiratory hazard for animals and humans. Okay? When we say contaminate water, think about all this toxic material going into your water supply and entering your water tables. It will cause death, and days and weeks and even months after a volcano, we still can't use none of the facilities available. Lava flow. Lava flow is not just explosive volcanic activities that can be hazardous. Effusive lava flow or lava activity can also be dangerous. So not because it don't pitch up into the sky and damage everything in its path or become so explosive is not dangerous. Running lava, effusive lava, is also dangerous. This is fast flowing lava, but it's not cold, it's very hot, so it will burn everything in its way. So for example, our lava flow is Jaime in Iceland. This was in Iceland in January 23, 1973. There was large fissure eruption which threatened the town of Vesuvius. Okay, so this is the lava flow and this is the town. Not because it wasn't explosive, people didn't take it light. It's still running out and towards where the population might be. The lava flows caught the inhabitants by surprise, and maybe by surprise because of the speed at which it was flowing. Before the eruption was over, approximately 1/3 of the town of Vesuvius had been destroyed. However, the potential damage was reduced by spraying seawater onto the advancing lava flow. So they attempted, they pulled holes near to the coastline and they sprayed seawater. It's just like you're out in a flame with water. They try to do the same thing. They try to cool the lava flow. This caused them to slow and stop or divert them. So even though, let's say the lava is flowing like this, and they are pitching out water this way, it will cause here to become solidified. It will cool it, so it will stop, but it can also take a next course. Okay? So it diverted them away from an undamaged part of town. So let's say this is the whole town here, and we're trying to save it, so we just throw water here, it cools here, and then it diverted to a part that wouldn't really cause a lot of damage then. So how do we minimize the risk of volcanoes? We can do volcanic monitoring, right? There are scientists and geologists who will study the Earth's crust and monitor earthquakes, any disruption to the crust of the Earth. And from this, we can determine if a volcano is going to erupt, and we can send out signals and clear the way. Volcano observations are set up on all active volcanoes that threaten the human population. These are designed to monitor and potentially to predict the eruptive behavior of volcano in question. So there's different machines and geophysical measurements and ground deformation, seismicity, and hydrology, different equipment that will use to determine how the volcano is going. If is it a dormant volcano? Dormant volcanoes are the ones that hasn't erupted in over 50 years, so it's dormant. And then we have passive volcanoes, and these erupt from time to time. And then we have active volcanoes, in which activity is always taking place. Seismic deformation and gas output on volcano and remote sensing techniques. These are things that are most important precursors to an eruption, right? So seismic activity, deformation or shifts in the land, and the gas output are three things that we use to monitor if a volcano is going to erupt. Seismic activity. Earthquake activity commonly precedes an eruption. Result of magma pushing up towards the surface, increased volume of material in the volcano shatters the rock, and this causes earthquakes. Okay, so earthquake is a good signal that a volcano is going to erupt. Earthquake activity is measured by seismographs, as we would have seen in our previous lesson. Seismographs are stationed on the flanks of the volcano. So that's like the outskirts of the volcano. These records the frequency, duration, and intensity of earthquakes and reported back to the Volcano Observatory, and they will keep their measurements and look at the activities of the volcano. Obviously, the more earthquakes, the more activities, it's really close for a volcano to erupt. Deformation monitoring. So we use tilt meters, which are used to measure the deformation of a volcano. The tilt meter measures change in the slope as small as 1 per million. A slope change of 1 part per million is equivalent to raising the land on a board 1 kilometer long, only 1 millimeter. So the tilt meter could determine if there was a slight change in the land or a slight drop in the land, right? By up to 1 millimeter. Tilt meters can tell you when new material enters the magma chamber. Note the presence of the earthquake in relation to the deformation often is a combination of events or forewarns of eruption. So basically, earthquake and deformation activity are just two signs to tell us that a volcano is going to erupt, right? So this is the tilt meter here, and this is the elevation of the summit. The summit is the very top of the volcano. This is the reference data. This is the magma chamber. When large volume of magma increases in the chamber, it causes the top to, like if you eat too much food and you have a little belly growing, right? It causes a belly on the outside. So the volcano swells up a little bit because of this rise in heat and gas and dust inside the volcano. So the tilt meter was once straight, and when the magma builds up and the pressure builds up in here, it causes the whole shape to turn from flat to a circular shape, and this tilt increases. So it's now from here, from straight cut to up like so. And this changes the whole appearance of the cone of the volcano. So when the volcano looks something like this, it will now look something like this, because it's of the pressure building up and then explosion happens after. Gas monitoring. Commonly, gas output from a volcano increases or changes composition before an eruption. As magma rises to the surface, it releases, exhaled much of the gas content. So before a volcano erupts, it releases gas, and this gas is very sulfuric and you can smell it from a distance. And this is how we can measure that a volcano is near to erupt. So all the materials bubbling inside the volcano into the chamber and ready to explode, right? It come like you're cooking and you're smelling the food, the steam and whatnot. The gas is what tells geologists that the volcano is going to erupt. And volcanic fumes are hazardous to your health and may be life-threatening. Gas monitoring. Gas samples are collected from fumaroles and active vents. Fumaroles are like little cracks, as you can see here, or the actual vent. Gas levels may also be monitored by remote sensing techniques. So basically, it's just like how you would test the air. We would use that to determine if there are any impurities in the air or gases. In summary, Volcanoes are extremely hazardous. However, the volcano can be studied, monitored, and understood in order to reduce the impacts of it. Each volcano is different and offers a unique set of dangers. So we have the composite cones, which looks like the straight volcanoes, and these are usually flowing down, and maybe the pyroclastic flows and the active volcanoes come like that. Then we have the fissure volcanoes, which is very effusive. It looks basically flat and material just flow out very slow from it. This is basaltic volcanoes, right? So this we have a regular composite cone. And then we have our basaltic volcanoes, and they form plateaus, which is like flat surfaces on the land, okay? Plans may be in place to help control potential damage, but always precaution will eventually cause protection. So to reduce the lives and the fatalities in a volcano, careful monitoring must be done. A little common sense could be applied too. So if you know there's a volcano nearby, don't go and reside. Do not open up any business. Keep it blank. Keep it clear. So in the event of an eruption, it do not hamper everyday life of the people. So are there other volcano-related hazards? There are noxious gas. 1,700 people living in the valley below Lake Nyos in the northwestern Cameroon mysteriously died on the evening of August 26, 1986. And this is because before the volcano erupted, there were gas release. Lake Nyos is a crater lake inside a dormant volcano. So a crater lake. So when a volcano don't erupt for hundreds of years, the vent eventually closes. So it forms like a plug here. And then with rainfall and overflows, water forms here. So it forms a lake. So this is not actually a regular lake that you'll see. A crater lake is when a dormant volcano, a volcano don't erupt as much as it should. A dormant volcano is a volcano that did not erupt maybe to 50 to 100 years. Because of this, the material inside causes a plug. It plugs it, corks it, and water deposits there and form a lake. Now, people go and look at the water in the lake, and there are fishes in the lake depending on how much years, right? This entire lake that you see in here is the top of a volcano, right? And the lake had become laden with carbon dioxide gas. So the water composition changed with carbon dioxide. This gas suddenly bubbled out of the lake and asphyxiated nearly every living being in the surrounding valley. A management plan has been developed to remove gas from the lake to prevent further tragedy. An artificial vent to the surface was created with a pipe. Water is pumped from the bottom of the lake to the surface through the pipe where it can degas, and then it goes back into the lake. So instead of the gas just causing havoc to the atmosphere, they put a plan and build a plant system that purifies the water or degas it before it goes back into the lake and having a noxious gas that could possibly kill a population. So these are some people in the crater lake. It looked very much deep, right? But that always remember below there is a volcano. And imagine this volcano has to erupt, how it's going to be. So these are the noxious gases. This is the procedure of the plant pulling the water and just degassing it and sending it back down. So the Lake Nyos incident was not unique. 2 years earlier, Lake Monoun, 60 miles to the southeast, released a heavy cloud of toxic gas, killing 37 people. A third lake, Lake Kivu, on the Congo-Rwanda border in Central Africa, is also known to act as a reservoir of carbon dioxide and methane, which is valuable natural gas that is gathered from the lake and used locally. So people now use this carbon dioxide and methane gas for other purposes, right? Maybe to generate electricity, to use in vehicles, etc. Now, there's a large volcano in Africa, and you can basically see it if you go on Google Maps. That will, the size of that volcano is like the entire Caribbean fit. The vent of that volcano is the entire Caribbean fit in there, or can fit in there. Okay, it's that huge. And if that erupt, it's going to cause a lot of shift to the plate tectonic activities and the movement of the plate. So earthquake is another hazard of volcanoes, and large volumes of magma moving through the shallow crust can cause large earthquakes. This can lead to building collapsing, slope failures, and avalanches. So this is an example of an earthquake. So destruction after a volcanic-induced earthquake in Japan. So after the volcano erupted, they had earthquakes and large fissures and cracks was in the road, building collapse, all the signs. And earthquake in itself creates a hazard. Remember, one hazard of an earthquake is a tsunami, right? So it's always a never-ending effect. So this was my lesson on earthquakes. I hope you've been reading the handout that I posted on earthquakes and volcanoes. It's one handout that was merged for tectonic activity, and I find it very useful. I hope you read and make your notes, and I hope you watch this video tutorial, take your notes, understand the effects of volcanoes and so forth, because it is very important, especially for those doing geography. Again, pause the video and make your notes and answer all questions that is posted at the end of the lesson. So thank you so much for watching this video tutorial on volcanoes.